Hi everybody, welcome to another video in Calculus 1, section 3.4, the product and the quotient rules. So in this section is straightforward, product rule and the quotient rule. And we're not focused on how to prove it, how to prove the product rule. The quotient rule we cannot prove it yet, but if you want to see the proof, you can see the proof in the textbook, but now we'll just focus on how to use the rule, which is a lot more important. Right, so the product rule we can write in that notation, but more convenient, we're going to use this notation as the product rule. So derivative of the first and the second is derivative of the first times the second plus the first time derivative of the second. Right. Later on there will be a systematic way that we see how that works. But let's look at this example. Right. So find the following derivative with and without the product rule. So we're going to do both. So first, using the product rule, and that obviously is u is the first one, v is the second one, right? So the product rule is the case. This is u, this is v. So we write out u is equal to x cubed minus 8 and v x squared plus 2x. Now we check derivative. Derivative of x cubed is 3 times x of 3 minus 1. I'm not going to write 3 minus 1 anymore. I just say 3x squared. Derivative of v, derivative of x squared is 2x. Derivative of 2x is 2. Right? And then so this is y. So if I want y prime, it is going to be the derivative of the product rule. U prime v plus u v prime. I should have more space, or I need to write smaller, but right. U prime v plus u v prime. Right. I guess I have to continue on this piece of paper, multiply it out. 3x squared plus 3x squared times x squared plus 2x plus x cubed minus 8 times 2x plus 2. If I multiply this out, I will have 3x to the 4th, 6x cubed, 2x to the 4th minus 2x cubed minus 16x minus 16, right? 2x to the 4th, 6x cubed, 2x to the 4th, 2x cubed, and that. So combine like terms, the 4th, that gives us 5x to the 4th, the cube, that 8, and minus 16x minus 16. So I'm just going to write the answer. 5x to the 4th plus ax cubed minus 16x minus 16. Right, so that is where we use the product rule. Sorry, I'm running out of space, so we just have to do it on here. Right, so that is with the product rule. Now without the product rule, what can we do? Of course, we tried something like this in the previous section. So let's say we have y equal to x cubed minus 8 x cubed plus 2x. if we don't want to use the product rule, perfectly fine. In here, just multiply it out. X cubed times x squared, that's x to the 5th. X cubed times 2x, that is 2x to the 4th, minus ax squared, minus 16x. And then we just take derivative. Derivative of x to the 5th is, I guess I still can do that, 5x to the 4th. Derivative of 2x to the 4th, x to the 4th will be 4x cubed. And there's a plus 2 multiplied to it. And x squared is 2x, derivative that is. And then we have minus 8 multiplied to it. And derivative of x is just 1. And we have 16 multiplied to it. So that is 5x to the 4th plus 8x cubed minus 16x minus 16. And then you say, why do we have to use the product rule? I agree. Maybe not on this one, we don't need to. But when the problem gets complicated, not that complicated, when we have something that we cannot multiply now, for example, when we have cosine of x times x plus 5, for instance, something like this, we cannot multiply it out. So in that case, the product rule will be useful. But we talk about the trig function in later section. For now, just a product rule will be that. And it works with or without it. Right, next, we have this problem. That is square root of x. By the way, since we up to this point the only rule we know is the product rule, so we'll rewrite the square root of x as x to the 1/2 before we do anything. So we write this function as x squared x to the 1/2 minus 3, and we use the product rule from here, u and v. So u is x squared, derivative of that is easily done to x. V is x to the 1/2 minus 3 v prime. Derivative of that, derivative of x to the 1/2 is 1/2 x. Original power 1/2 minus 1. 1/2 minus 1 is negative 1/2. Derivative of 3 is a constant, so that will be 0. So that's what we have. Right. So the derivative of a product will follow by the product rule. Right. So u prime to x, x to the 1/2 minus 3, that's v, plus u x squared times v prime will be this. Right. U prime v, u v prime. Right, multiply this out. X times x to the 1/2. When we multiply this, we add the exponent to x times x to the 1/2. By default, this to the first power, 1 plus 1/2. When we multiply them, add the exponents. 1 plus 1/2 is 3/2. Minus 6x. And then plus 1/2. When we multiply this, we subtract the exponent. We add the exponent. 2 plus negative 1/2. 2 plus negative 1/2. So that will be 3/2. And finally, combine like terms of x to the 3/2. So that gives us 5/2. x to the 3/2 minus 6x. Right, so that is with the product rule. Now without the product rule, meaning that we can multiply them out. So I will start with this. And multiply it out. Multiply this 2. Add the exponent. 2 plus 1/2 is 5/2. And multiply it out, minus 3x squared. By the way, if we write the equal sign like this, that means they are equal. And meaning that we haven't done any derivative yet. When we start derivative, that will be a different line. So I'm not going to say the derivative start from here. I mean, I will say this, derivative start after this line with the notation of derivative. Right. Now for that, it's easy, right? Power rule says original power moving down, and then the original power minus 1. 5/2 minus 1 is 3/2. Of course, if you use a calculator, 5/2 minus 1 is 1.5. Hit math, and that's 3/2. Or you can just use the fraction alpha y equal to 5/2 minus 1. That is 3/2. Either way, it works like that. So original power minus 1, which is 3/2. And then minus 3. And then derivative of x squared, that's easy, just 2x. So we have 5/2 x to the 3/2 minus 6x. And once again, we said, why do we have to use the product rule? And then once again, I will point to some example like this, where we have to use product rule, where we cannot multiply them out. If you can multiply them out, by all means, do that. Derivative will be a lot easier if we can just multiply them out. Right, so that is the first part of the section, the product rule. Next, the quotient rule. Once again, if you want to see the proof, it will not be in this section, it will be in different section. But for a simple version, we're going to just look at this one. So the derivative of a product of a quotient is the top derivative of the top, the bottom, minus the top times derivative of the bottom over the bottom square. So it's always UV. The way I would memorize this when I took calculus 1 is this. Say we have two terms, right? Derivative. I'm going to write the product again 2 times, and then the derivative will be from the first to the second. Like I said, how did that help? How's that easy to remember? Well, if you look at if there are 3 terms, then you will have 3 products. And the derivative will go from the first, the second, to the third. Now on, I hope you see the pattern. If the product of 2 terms, the product rule will have 2 products. The derivative jump from the first to the second. If there are 3 terms, there will be 3 products. The derivative jump from the first to the second to the third. That's how it works, and that's how I memorize it. Now, the quotient rule will be kind of similar to that, but it is minus, but over v squared. Right. Now we have an example here: x squared minus square root of x over x. Because we're going to use the product rule. I mean, we're going to use the quotient rule anyway. I mean, we're going to use the power rule, so we're going to write square root of x is x to the 1/2 times x. By the way, if you want to use the product rule, you're welcome to do so. When we rewrite like this, if we move this x from the bottom to the top, of course that worked as the product rule. If you want to, just go with this, and that's work perfect. It will be the same. Right. So, and once again, we're going to do this with the quotient rule and without the quotient rule. First, using the quotient rule. So if that is the case, then we say u, which is the top, x squared minus x to the 1/2. V, the bottom, is x. U prime derivative of x squared is 2x, and derivative of x to the 1/2, the power goes down, original power minus 1, so that's minus 1/2. 1/2 minus 1 is minus 1/2, so that is the derivative. Derivative of x is 1, so we have u, v, u prime, v prime. Then we can find the derivative using the quotient rule. So derivative of y, which is derivative of a quotient, which is u prime v minus uv prime over v squared. Right, and just put everything into that formula. U prime v forgot the power. U prime v minus u v prime over v square right. I'll just multiply this out. 2x times x, that's 2x squared, minus 1/2, of course, and x to the negative 1/2 times x. By default, this is to the first power, and when we multiply, we add the exponent. Negative 1/2 plus 1, negative 1/2 plus 1 is 1/2. And then be mindful with this minus, with this negative sign in the product rule, in the quotient rule. It will affect everything after that. So x squared times 1 is x squared with the negative x squared. Negative x to 1/2 times 1 is negative x to the 1/2 with the negative, positive. X squared, right? Now suddenly we can combine last terms on the top, right? 2x squared minus x squared, 2 minus 1, that is 1. And then minus 1/2 plus 1, those are like terms, x to the 1/2 minus 1/2 by default is 1, negative 1/2 plus 1, that gives us positive 1/2 x to the 1/2. Right, just keep it like this for a moment. We might get back to this later. But now let's use that without the quotient rule. So without the quotient rule, y equal to x squared minus x to the 1/2 over x. Right, so without the quotient rule, of course we can use the quotient rule by doing this. But if it is without the quotient rule, I prefer to just write as x squared over x minus x to the 1/2 over x. So what I did there is I just split the top, and that's what we have here. Now, when we divide, we subtract the exponent 2. By default, this to the first power. 2 minus 1 is 1. So x squared over x is x to the first power, or just x. X to 1/2 over x. When we divide, we subtract the exponent 1/2 minus 1. So that minus 1/2. Just like that, right? 1/2 minus 1. When we divide two things with the same basis, we subtract the exponents. Right, now we take derivative. Derivative of x is 1. Derivative of this take down the power, and the original power minus 1 minus 1 half minus 1 is minus 3 half. Minus 1 half minus 1, negative 1 half minus 1 is negative 3 halves. Just make sure put the parentheses around that. So this is equal to 1 minus a negative, so that turned to positive 1 half x to the negative 3 half. And of course that, well, not quite the same yet, but on this one, if we want to make it look the same, we can always split the top like we did here. X squared over x squared is 1, and then we have 1 half. When we divide these two, subtract the exponent, 1 half minus 2 minus 1 half, which is 3 half. Of course they are the same now, and that should be right. By the way, if you don't want to split like this, we can always move the x to the top, become x to negative 1, and then you multiply it out. And multiply it out, x squared times x to negative 1, add the exponent 2 minus 1 is 1. And then subtract, again add the exponent 1 half plus negative 1, or 1 half minus 1 is minus 1 half. So either way, we can split the top, or we can move the bottom to the top. I prefer to do this when we split the top, and to simplify over doing this. Right, and then once again you ask, why do we need the quotient rule for when we just do this? And in this case, I can give an example in this section. How about that? And so what's so special about this? Remember, on this problem we only have one term at the bottom, where splitting the top allows us to simplify things. On this one, there are two terms at the bottom. We cannot split, even though if we split, we have x squared over 2x squared minus 1. We cannot do this without the quotient rule. So bottom line is, when the bottom has more than one term, when we cannot split that, then the quotient rule will be very helpful here. So quotient rule, U is the top, V is the bottom. Derivative of that, derivative of x squared, 2x, derivative of 3x, 3. Derivative of V, the derivative of x squared is 2x, so 2 times 2x, or 4x. So we have U and derivative, V and the derivative. It's ready for the quotient rule. Just substitute everything in to the quotient rule. U prime to x plus 3 times V to x squared minus 1. Subtract U times V prime over V squared. Right, we'll multiply them out and we'll simplify. 2x times 2x squared will be 4x cubed. 2x minus 1, 2x times minus 1 minus 2x, 3 times 2x squared, that's 6x squared minus 3. And then, like I said, be mindful with this negative sign. X squared times 4x, that's x cubed. 4x cubed. But with the minus. 3x times 4x, that's 12x. But with the negative. 4 times, that will be 16x. I mean, sorry, this will be x squared. This will be 3x times 4x, 12x squared. 4 times 4x, 16x. Again, with the negative sign. The bottom, 2x squared minus 1. Right, combine like terms. And don't forget to square at the bottom. Right, the top combined like terms, 4x cubed and 4x cubed, well, that cancel out. X squared, how many x squared we have? 6x squared minus 12x squared minus 6x squared. And the x, negative 2, negative 16, negative 18, x. What's left? Negative 3. Right, so that's what we have. Right. Right, go to this one. Find the equation of tangent line to the graph at the point 3 and 2. Right, so equation of a tangent line minus the values of the function slope of the tangent line x minus a. Right. So in this case, the function is that. So when we find the slope, it has to be a quotient rule. So first, the slope of the tangent line is equal to the derivative at 3. Right. So first, this is the function. I will just rewrite the function. Then let's take derivative. Then we substitute 3 in for x. Right, u is the top, x squared plus 1. U, x squared plus 1. V, the bottom, x squared minus 4. Derivative, 2x. Derivative, also 2x. So now we put in the quotient rule to find derivative of the function. Quotient rule. Right. U prime V minus U V prime over V square, V square. Right. So we continue. This is the derivative. Multiply it out. 2x cubed minus ax. X squared times 2x is 2x cubed, but I have to negate that. And minus 2x all over x squared minus 4 squared. Right, simplify. X squared minus 4 at the bottom square Right, 2x cubed minus 2x cubed. Good thing I did that in pencil. Give us negative 10x. Right, now we just need to put 3 into that. So derivative of 3 so we just say 3 store into x, right? And then we just enter the function. Negative 10 x divided by x squared minus 4 squared negative 6 over 5. Right, so is there a way to confirm that it is the case? Well, certainly we can. If we take derivative, evaluate at the number, we can check using the calculator. It's math. Go down to option number 8. Let's set numerical derivative. Derivative with respect to x. And the function is a fraction, is a quotient, x squared plus 1 over x squared minus 4. We will evaluate when x equal to 3. And we have that. And if we take negative 6 divided by 5, because that's negative 1.2, so of course that number is numerical error. Like I said, the calculator only can estimate the answer. They could not calculate the derivative exclusively. So we just do the estimate, which is close to what we have here. But close is not enough in this case. We have to take derivative to get the exact values. And we put the numbers, we have the exact values. Yeah, the calculator, yeah, you can check. But yeah, it's much better to do it by hand. Anyway, so now we put it back into the equation. Y minus the values of the function times the slope of the tangent line, x minus a. Right, y minus the values of the function. If we are not given, we need to put 3 back into this function. So by the way, 3 store into x, and then fraction of x squared plus 1, x squared plus 1 over 4 x squared minus 4 is 2, of course. That's what we have already, so we don't need to do that, but I just want to check. If it's not given and it only say the tangent at x equal to 3, then we have to do that. The slope though, negative 6 over 5, x minus a, 3. So in this case, of course, a is x values, which is 3. Multiply it out, y minus 2 equal to negative 6 over 5x. Multiply this out, 3 times 6 is 18 over 5. And then add 2 on both sides. So I have y equal to negative 6 over 5x. And that plus 2 will be 28 over 5. How about fraction? 28 over 5. So that's what we have. Yeah, so the quotient rule is that. Right, let's look at even more examples. Find the derivative of this function. Now the interesting part here is, if we don't want to, we can always multiply this out. But the fact that we don't need to. Right, so the qubit, how about 4th power, how about 5th power, because it will get things more complicated, right? But let's not multiply it out. But what we have here is the cube, so it will be 3 of them, right? And what did we say about derivative of the product rule of 3 terms? Will be first, second, and third. There will be 3 of them, right? Where derivative will go from the first to the second or to the third. Now, we don't need to multiply it out though. We just say that the derivative will be, there will be 3 of this, right? Very small. Oh, I think it's just enough. Right. Derivative though. The product rule will be derivative of the first, second, and then the third. Derivative of 2x minus 1 is 2. So when we do this, we have 2, and then 2x minus 1 times 2x minus 1. Make it square, right? So derivative here is 2, and then multiply that, is a square. Now we have that factor, and then the middle is 2. So we also have 2 to x minus 1 square as well. And the last one, 2 to x minus 1 square. To x minus 1 square, and then derivative is 2. All of them are the same, combine like terms. 2 plus 2 plus 2, 6 to x minus 1 square. Yes. And this is an example where we're showing that when we have the product rule, we don't even need to multiply it out to take derivative. And so derivative is like that, which is better than, yeah, of course, if this is cube, but if this is to the 10 power, we're going to have 10 of this. It's still much better than multiply it out if there are 10 of them, right? So, yeah. So that's why we do this one. Right. Next, how about when we take derivative of something like this? Notice that first thing we have is the product, and then of course obviously the quotient. But somehow if we can simplify the problem, do that, and I will do just that. I will multiply it out first. 4x times 2x cubed. That gives us 8x to the 4th power, right? And then 4x times negative 3, x to negative 1, 4 times negative 3, that's negative 12, x times x to negative 1. When we multiply two things with the same basis, combine the exponent. By default, the exponent is 1. 1 minus 1, that's 0. And x to 0 power is 1. So let me just write this. 4x times 3, negative 3x to the negative 1 is negative 12. X, combine the exponent 1 minus 1. That gives us negative 12x to the 0 power. Anything to 0 power except for 0 is 1. So negative 12 times 1, negative 12. Right, so that's what we have. So when we write like that, it's much better. So on this one, don't use the product rule on the top and then with the bottom. It's just confusing. We don't need to. Try to simplify, just have the top and the bottom. So we use the quotient rule. U is the top. V is the bottom. Derivative of that, x to the 4th, 4x cubed. Derivative of x squared plus 1 to x. Of course, that will be 32x cubed. And then 2x. Right, quotient rule. Derivative of a quotient uv minus uv derivative on the outside. By the way, one thing to note that in the product rule, because of the plus in the middle, you can write u prime plus v, u prime v plus uv prime, or you can write uv prime plus u prime v. You can switch, you can interchange in the product rule. This is a minus, so you cannot interchange them. So it has to be exactly in this order. You cannot switch those two. That's what I mean. Alright. U prime v u prime v plus subtract, right? Subtract u v prime over v square, right? Just multiply it out the top, combine like terms, as always, be mindful of that negative sign. So 32x cubed and x squared, that's 32x to the 5th plus 32x cubed minus, right, ax to the 4 times that will be 16 x to the 5th, right? And that negative, make that negative. And then negative 12 and 2x, that negative 24x. But with that negative sign, make it to positive. The bottom square. Right, so little x to the 5th right. Combine like terms on the top. We only have x to the 5th here and here. 32 minus 16, that is 16. Plus 32x cubed plus 24x. Right, that's what we have. Next we have application problem. Suppose that the population growth is population is modeled by this, where t is time in hours, so it's like that. Right, compute the instantaneous growth rate. So pretty much when we talk about rate, that means the derivative. So we will take the derivative of that. By the way, if I rewrite this, it's much better if I multiply 400 on the top. Because it's much nicer if we just have one big quotient, one top, one bottom. By the way, when you multiply that number, only multiply to the top, don't multiply to the bottom. We don't distribute like that. Just multiply to the top. That's what we have. Right, now from here, because that is the quotient, if we want derivative, quotient rule, right? Quotient rule, the top is 400 t squared plus 400. The bottom, t squared plus 4. Derivative of 400 t squared plus 400 is 400 times derivative of t squared is 2t. That's 800t. Yeah, later on I just write 800t, but for now, yeah, just 400 times 2t. Derivative of t squared is 2t, and then that's all what we have. Now, the derivative instantaneous growth rate, that is derivative with respect to t, which is a quotient. Derivative of a quotient is a quotient rule. right? U prime 100t v minus u v prime over v square of course multiply them out and simplify the top. One thing that you don't see me doing here is that I don't multiply out the denominator to just keep a square at the bottom. That's usually the case. The derivative in the quotient rule, usually when you multiply now, you're not going to simplify with the bottom. So usually we're just going to keep a square like that. Right, multiply them out. 800t, that's 800 t cubed. $800 times 4 is 3200 t minus 2 times that is 800 t cubed with the negative like that. I don't emphasize enough. Be mindful with that negative sign. And 400 times 2t. That. Right. Now combine like terms on the top. Those cancel out. The 3200 minus 800, 2400. (2400t) over t square plus 4 square. Right. Now, if we put on the graph, we have the population going like this and the derivative going like this. What we see is that the growth rate as t going to infinity, that gets smaller and smaller to 0. So that makes sense because the population, even though it is increasing, but it cannot get past the carrying capacity, which is the maximum possible population. So when we call the carrying capacity, which is the maximum capacity that it can hold. For example, if we talk about an island can only hold some certain people, certain amount of people there. I'm talking about not just the space for them to stand, but I'm talking about the resources for them to live. For example, in an island, there's only enough food for some certain amount of people. So in that case, the population, even though it's increasing, but will never get past that cap, that carrying capacity. So because the rate of change get, even though increasing, but instead of flat out, the growth rate here though, if we graph it, it goes to 0. So even though it is increasing, even though this is positive, but this will get smaller and smaller, and essentially the growth rate goes to 0. It's just the population will be flat out. And the question is, what will be the steady state population? Well, we just take the limit as t goes to infinity. So the limit of t, limit as t go to infinity of the population function (400t square plus 400 t square over 4 t square plus 4 at the bottom. Now we did this on chapter 2, right? Highest power at the top, highest power at the bottom, because when t go to infinity, the highest power matters, not the other two, 400 and 4. So only the 400 t square at the top, higher power, and then t square at the bottom. T square cancel out. This is just 400. So that makes perfect sense. The carrying capacity is 400. It cannot cannot get past that for 100. Even though it is increasing, but cannot get past that. Right. So in this section, we only have product rule and quotient rule. And of course, that's a product rule, and this is a quotient rule. That is straightforward. Just find out what is U, what is V, what is U, then find out what is U prime, what is V prime, and just put in the formula for the product rule and the quotient rule. So that should be fairly simple. Just need to do a lot of practice problem. I hope you find this video helpful. As always, thank you for watching, and see you in another video in Calculus 1.